You're about to create your first spinning part in only a couple lines of code. After this video, you'll be able to make any part rotate or move like this. We can actually change our part's size by adding to its existing size. So let's say we wanted to make our part 1 stud bigger in every direction, or 5 studs bigger in every direction. We can actually add to the existing size of our part. I'm going to erase everything in our script and start over from the beginning. We go to set our part size like normal with our vector3.new, but then we put a plus sign and add it to our part's size. So workspace.spinnerPart.size. Now, if we wanted to make it 1 stud bigger, we would go like this. Or 5 studs bigger, we would go like this. So if our part size is 4 for the x value, 1 for the y value, and 2 for the z value, it's going to look at this and add 5 to the x value, 5 to the y value, and 5 to the z value. So when we hit play and we select our part and go down to size, we see that the x value has gone up to 5, the y value has gone up to 6, and the z value has gone up to 7, which are all 5 greater than our initial part size here, the 4, 1, 2. Okay, and if we did this with a bunch of different numbers, right, now it's going to add 2. This is in XYZ order. So it's going to add 2 to our x value, which makes it 6. It's going to add 5 to our y value, which makes it also 6. I didn't do that on purpose. And then we're going to add 9 to our z value, which ends up making it 11. And now both these lines are doing the exact same thing. It's adding this vector3new to our spinner part size. Anytime you see this plus equals or this minus equals in the code, it's just adding or subtracting whatever is over here to whatever value is over here and then updating it. You can do this the same way with rotation or position. We've been updating our part size this whole time, but let's switch to updating orientation. This makes our part turn just like rotation. So write workspace.spinnerPart.orientation plus equals vector3.new, and in here we're going to put 0, 15, 0. Each of these spaces represents a direction the part will turn, and because we're adding 0 to these directions, the part won't change in its x or z direction. It will only change in one direction. I'm also going to go into our project, click on the part, and then make sure it's anchored so this is a little easier to see. I'm going to move it a little away from the stairs too, so it's just free floating and we can see exactly what it does. Notice how our part is turned right now before I hit play. Okay, so we see that our part is sort of at an angle. It's not completely straight with the grid that's on the ground, and that's because we've rotated it some. Now I'm going to add a wait 0.5, so we're going to wait half a second. Now I'm going to highlight all of this. I'm going to hit Control C. I'm going to hit Enter and then Control V, Enter, Control V, Enter, Control V, Enter, Control V. And this is just going to repeat these steps a couple times. And we'll put a wait 5 seconds at the very beginning so that none of this happens before our game loads. And hit play. And you see that it's adding to our position over and over again, making the part turn. But luckily, there's a really easy way to repeat code so that we don't have to copy and paste it over and over again like we just did. So while loops let you repeat any code you put inside them. I'm going to backspace what we updated, and on a brand new line, write while. Enter. So yours should look exactly like this. I'll explain what it means in a second, but for now, go up here and highlight this. Hit Control X and that will cut it, and you can hit Control V and that will paste it. I'm gonna move the wait 5 seconds out of our loop actually. So it's gonna wait 5 seconds before the loop even starts. Before you hit play, make sure to add an empty wait in here. Otherwise the loop is gonna repeat way too fast for the computer and it's gonna give you an error like I have down here. So now that you added the wait, hit play and let's see what's happening. It's gonna wait 5 seconds and then it spins. Cool, so let's add a print statement to actually see what's going on in our code. So I'm gonna write print, let's just copy this. So highlight, Control C, and then inside of our print statement, workspace.spinnerpart.orientation. So here on this line, we're updating our part's orientation, and on this line here, we're printing out the new orientation after we update it on this line. And because it's inside of our while loop, because it's between this while and this end, it's just going to repeat this over and over and over again. So hit play, we see that it's spinning and it's printing out our orientation as it changes. So if we wanted to see only the y-axis, we could actually go in here and change our print statement. So we're printing .orientation.y, and it will just print out a single value now, the y-axis, which is the one that we're actually changing. So you see that our orientation starts out low, then it goes up, and once it hits 180, it switches over and becomes a negative number before going back up all the way to 0. I'm also going to change this to 1 so it's a little easier to see once we run our game. So I'm going to hit play, and now that our part's turning, you see it's turning a lot slower because we're only updating our part by 1 every time. And we see that the number that represents our rotation is increasing from negative 180 all the way up to 0, and then going up to positive 180. You can think of this like how increasing minutes turns the rotation of the minute hand on a clock. Only with orientation, there's 360 degrees in a circle instead of 60. It also happens to go from negative 180 to 180, which makes 0 the halfway point down here. Honestly, this is confusing for no reason, but that's just how it works. So that's how orientation works. Let's go back to our while loop and we can put this orientation information to work. So in our while loop, we have this word true. And this part of our loop is called a conditional statement. That's like a fancy way of saying switch. And we can flip this switch by giving it something to check. If we write true here, our loop will always be on. And if we write false, it will always be off, meaning it never runs. But if we write something in here like workspace.spinnerpart.orientation.y is less than 0, here it's going to be true at first, but then when our part turns past 0, this equation becomes false, so the loop stops. So I'm going to go into our properties, and under orientation, I'm going to change it so the y value is less than 0. So let's make it negative 180. Okay, it's making it positive 180 for some reason. Let's do negative 179. All right. So now our part starts at negative 179. So when we run our code, it's going to wait 5 seconds. Then it's going to go into our while loop. The very first thing it does is says, hey, is our orientation.y less than 0? It is. It's negative 179 because that's what we just set. And so it says, okay, it's less than 0. This is true. Let's run this loop. So it goes, so we add 1, right? See, this is the 1. So we add this vector 3 new to our orientation, which updates our rotation on the y-axis by 1 degree or 1 minute, if you're thinking about it like a clock. Then it prints out the new orientation that we just did. So it goes from negative 179 to negative 178, and then it loops back around again. And it says, is our orientation still less than 0? Yep, let's run the loop again. It does the exact same thing over and over and over again until our orientation.y becomes greater than 0, at which case it stops. So let's see it in action. So there we go, it's spinning. Look at our orientation down here. What's going to happen when it hits 0? It stops, just like that. So we can write any equation here, and as long as it's true, the loop will run. So here's an extremely simple example. You could put like 4 equals 4. With a conditional statement, you always have to put these double equal signs. So 4 will always equal 4, so this will always be true, and our loop will never stop. Or you could put 4 equals 5, which is never true, so our loop will never run. But we want our part spinning the whole time, so let's just change this back so it says true. So now you know how to repeat your code using a while loop and use that to move your part. You can also do this on the position, which I will show you real quick. So it's going to wait 5 seconds, and then the position's increasing just like that. And see, our orientation isn't changing anymore because we've changed this from orientation to position. Okay, but I want it spinning, so I'm just gonna leave it on orientation. In the next video, we're gonna learn a trick to make it super easy to duplicate these spinning parts. So when you're ready, click on the next video.